Hi everyone, I continue on lesson topic 16, rate of change and tangent line and slope of tangent line. So I already talked about this lesson in topic 14 because I wanted you to know what is the reason you need to know limit. And we talk about limit and how to find limit and different skills for limit. Okay, so here I'm going to repeat a little bit at just the beginning of the lesson and then we continue. Rate of change and tangent line. So if I have a linear equation, just a line, okay, the average rate of change is the slope. The average rate of change is a slope. But just a few functions are linear and I have many curves, okay? So we do have many curves for many different functions. For example, like e power x, 2 power x, 2 power minus x, they are all curve, not line. So for a curve, average rate of change for a curve, if I say what is average rate of change, that's related to secant line. Means you have a curve, you have 2 points on the curve, you connect them with each other and you make a secant line. Then you would say, for example, like here, okay, so see, I have this curve, then I have 2 points on it, okay? One of them x is a, one of them x is a plus h, one of them y is fa, and one of them y is f a plus h, okay? Means a plus h sits instead of x, okay? So average rate of change for a curve is a slope of secant line, for every 2 points. Okay, what is the slope of secant line for this point? So a and fa, a plus h and f a plus h. Okay, what is average rate of change for this secant line, or which is a slope of secant line? Okay, a slope of any line is difference on y over difference on x. Okay, so it is f a plus h minus f a, which is difference on y, and a plus h minus a, difference on x, which is f a plus h minus f a divided by a, and a cancel, divided by h. Oh, okay, which is here in a box. Okay, I make it in a box, just I highlighted it in the box here. Oh, okay, so that's a slope of secant line. Then I would say, okay, so this is what I already know, but what is instantaneous rate of change? Instantaneous means I want at just 1 point. What is rate of change at 1 point? Not when I have 2 points. When I have 2 points, that's average, but I want just 1 point. So you would say, for example, which point? I say a and fa, okay, which is here, this point. Okay, I'm talking about that. Okay, so then you would say, okay, if I want to just use that point, it will be, if you remember from topic 14, it will be fa minus fa divided by a minus a, which is 0 over 0. So I don't want to do that. So I would say, okay, I choose a very close point to a, which is here. This is a close point to a plus h, and then I approach h to 0. When I approach h to 0, h is not 0. Remember, do you remember in limit, topic 15? H is not 0. When I say approaches, it is very close to 0, but it's not 0. So I don't have 0 over 0 then. Okay, so I take h, approach h to 0. Then when I do that, this point approaches to this point. Okay, so this point approaches to this point. This secant line approaches to this tangent line, which is the red one. The line that touches graph in two points just approaches to the line which touches graph in 1 point. And then a slope of black line approaches to a slope of red line, and then I find a slope of tangent line. Okay, so one more time. When I want to find a slope of tangent line which touches the graph in 1 point, which is the green point here, I have FA minus FA divided by A minus A, which is 0 over 0. So I cannot do that. I choose a very close point, which is A plus H. Okay, so I have FA plus H minus FA, and then I do difference on Y over difference on X, which is just H in the denominator. And then when I take H towards 0, this point on X, okay, here, approaches, A plus H approaches to A, okay, and then this is happening, which is Q approaches to P, that point on the graph. Okay, so maybe I remove it and I show it one more time. Okay, so here, okay, so this approaches to that, this approaches to that, their black line approaches to red line, and then I have so I would say, okay, if I find the limit when this approaches, then I can say, oh, okay, I found a slope of tangent line. Okay, so for a slope of tangent line, I need to know limit then, because I just have one point. And I already talked about this in 14, and I showed you what is the reason you need to know, limit. Okay, let's do this example. Okay, I have this graph. Where is this point? Okay, so 1 and 1 here, okay? So I want a slope of this line. I want a slope of this line. Okay, so how can I find it? Yes, as I said, it is f1 minus f1, okay, divided by 1 minus 1, which is 1 minus 1 divided by 1 minus 1, because it's y equal x squared and it's 1 and 1. Okay, point is 1 and 1, and that's 0 over 0. Okay, so I can't. What should I do? Okay, I start from 2. Okay, I have this second line. So I approach this to this, and this approaches to this, and this approaches to this, and then I can say I have a slope of tangent line, which is the blue one. Okay, so here it's just explaining, okay, that I start from 2 and 4, then I just move it, and I already talked about all of these. Okay, so I'm just going to fill just the table here. Okay, I start from 2 and 4. Oh, okay, so 2 and 4 and 1 and 1. Okay, so difference on y over difference on x. Okay, so 4 minus 1 over 2 minus 1, which is the slope. Okay, but remember, this is a slope of second line that touches this point to this point. This point to this point. Oh, okay, so now I continue. I would say, okay, I approach my point towards 1. So instead of 2 and 4, I move to 1.5. And I just have y here. Okay, so slope is 2.25 minus 1 over 1.5 minus 1. Okay, which is 2.5. Okay, so now I continue. I go closer to 1. Okay, so 1.21 minus 1 over 1.1 minus 1, which is 2.1. Okay, so I go closer. It is 1.0201 divided by this minus this divided by this minus this. Okay, which is 2 point that. Okay, so I continue here. 1.002001 minus 1 divided by 1.001 minus 1, which is 2.001. Okay, so what is your conclusion here? Your conclusion here is when you look at this, you see, okay, it starts from 3 and then go to 2.5 and then 2.1 and then 2.01 and then 2.001 and then if I continue 2.00001. Okay, so the conclusion is a slope of tangent line. The conclusion is, I can write here, a slope of tangent line at x equal 1 for x squared, for y equal fx, which is x squared, okay, is 2. That's your conclusion when you look at the table. Okay, you start something close and you go closer and closer. Okay, so maybe I can make this red. Yeah. Okay, so then maybe you have one question, that how do we have these numbers? Okay, these numbers, I have y equal, okay, so I have y equal x squared. So I do 1.5 squared and then I find this answer. 1.5 squared. So 1.5 multiple 1.5, which is 2.25. Here 1.1 squared is 1.21. Here 1.01 squared is this number. Okay, so because I have y equal x squared, that's my function. So for any point I can find y. Any x you give me, I can give you y. Okay, so then you would say, oh my goodness, every time for every tangent line, do I have to do that? Do I have to choose a close point and then go toward and then guess? I say no, you can use the method that I already said. Which method? Limit. Okay, so by limit, oh, okay. I have y equal fx, which is x squared. Okay, that's my function. What do I need? A slope of tangent line at 1 and 1. Oh, okay, a slope of tangent line at 1 and 1. How do I know 1 and 1? Okay, if I put 1 for x, I have y equal 1, right? Okay, so it is limit f, tell me, a plus h, do you remember? So 1 plus h minus f1 divided by h goes to 0. Oh, yes, okay, so, which is limit 1 plus h squared minus 1 over h goes to 0. Okay? You would say, okay, if I put h equals 0, then it will be 0 over 0. I say, okay, remember limit. You can expand. Okay, you have 0 over 0, so you would say, okay, I can do that. 1 plus h squared plus 2h minus 1 divided by h. h goes to 0. Okay, 1 and 1 cancel. Then I have limit h times h plus 2 over h goes to 0. Okay, h and h cancel. You have limit h plus 2, h goes to 0, and the answer is 2. Okay, so this is the answer, which I guess, but I have the answer. Oh, okay, perfect. I don't need to go through all of those calculations. So, if I have a function, this, and if I want to slope of tangent line at this point, I can use this method. This is the formula. Remember this. Okay? So practice here. So this practice is asking what is the slope of tangent line for this function. Oops. I wanted to highlight. For this function, oh God, this function at this point. Okay? So, yes, look at the table. You can start from very close point, 0.9, 0.99, 0.999, and go close to 1. Or 1.1 means Here you do from left. Here you go from right. Okay, you go towards 1 from right. Then you need to do many calculations. So I say, don't do that. What is the function? To x squared plus 2x. Oh, okay. So limit f, which point is that? 1 and 3. So f1 plus h minus f1 divided by h goes to 0. What is my function? Okay, limit x squared plus 2x, yes? So 1 plus h squared plus 2 multiple 1 plus h minus 3 divided by h goes to 0. Limit 1 plus h squared plus 2h plus 2 plus 2h minus 3 over h goes to 0. Because at the beginning, okay, let me show you this. At the beginning, if I just substitute, it will be 0 over 0. Okay, so as I said in limit, I taught you that you have to expand it. Okay, so limit 1 plus h squared plus 2h based on Pascal, 2 plus 2h minus 3 over h over h. Okay, so h goes to 0 is, okay, let's cancel 1 and 2 and this cancel each other. Okay, then it is limit h squared plus 4h over h goes to 0. Now I factor, because it still is 0 over 0. Now I factor limit 4 over this h goes to 0. Okay, and this cancel, and this is limit this h goes to 0, which is 4, and that's really the answer. Okay, that's really the answer. So a slope of tangent line for this function at this point is 4. Okay, how about this one? Okay, a dry air moves upward, it expands, cool, according to this equation. Okay, so this is like a function. T is temperature, h is the height. Okay, so look at this. T of h is 20 minus h squared. It's exactly like f of x. Okay, find the slope of tangent as the height approaches to 2 kilometer. Means we want a slope of tangent line, at 2 and 20 minus 2 squared, which is y. That's 2 and 16. Oh, okay. So it is limit t. Okay, limit t. Where is it? 2. Okay, 2 plus h minus t2 divided by h goes to 0. Okay, which is limit 20 minus 2 plus h squared minus 16 over h goes to 0. Okay, if I put and substitute h equals 0, it is 0 over 0. This is 0 over 0. Okay, I can't. Okay, so I have to cancel. I have to do something. I have to clear. I have to make my limit clear. So I do limit, I expand 20 minus 4 plus h squared plus 4h. Let me just fix this just as a, yeah, this one, minus 16 over h goes to 0. Okay, so which is limit 20 minus 4 minus h squared minus 4h minus 16 over h goes to 0. So then I can say, okay, so 20 minus 4 is 16, minus 16, they cancel each other, okay, and then I have equal limit minus h squared minus 4h, oops, this pen is really killing, okay, minus 4h divided by h goes to 0, okay, so which is limit, yes, I factor minus h plus 4 divided by h goes to 0. Now I cancel h and h, and it is limit minus h, oh my god, minus h minus 4, h goes to 0, yes, and the answer is minus 4. Okay, so the slope of tangent line for this function, okay, for this function at this point, which is 2 kilometer, is minus 4. Okay, so here the question wants you to start from something close and just approach, but I don't recommend, because you already know how to find the answer. You can find it. Okay, so this question, if a slope of this is 1 over 2, given that the slope of PQ is 1 over 2 and the point Q is 1 and 5, find the equation of the line. Okay, so what do I have here? Oh, I want, this is just an example about line. Okay, so I have PQ, I have the slope. Okay, so I have y equal mx plus b, which is x over 2 plus b. Okay, it says that's a slope. Okay, so I just substitute. So I have one point which is 1 and 5, and find the equation of the line. Okay, so I want to find b, just b. Okay, so 5 equal 1 over 2 plus b, and b is 9 over 2. Okay, so I have y equal x over 2 plus 9 over 2 is the answer. Okay, which is related to lines, and just a good question for that. Okay, so here you have a very similar question. So see, you have the slope, you have another point, and you want to find the equation. So I recommend you do this on your own. We are done by this lesson, and we are done by this video as well. I will continue to topic 17 in the next video. Thank you.